Angle of repose. What is angle of repose? Let us imagine a situation. If the block was placed on a rough horizontal surface of coefficient of friction mu, what happens? Its own weight will act downward, and since there is a contact between the block and the rough horizontal surface, there will be normal force. And here normal force is well balanced with its own weight. But now just imagine if this surface start making an angle of inclination, if it is going up, if it is lifted up to an angle theta. So what happens? This is the mass m. Its own weight always acts downward because acceleration due to gravity always act towards to the center of the earth. But now normal will be also rotated by an angle theta. So what does it mean? So this is also be theta. So this will be mg cos theta, and along the inclination mg sin theta will act. Since it is a rough inclined plane, so a counter frictional force will act. So what happens? The block will be remains constant. But if the angle of inclination for this inclined surface, if it is increased, what happens? When the angle of inclination is keep on increasing, at certain point the block will about to move, right? So let us imagine a situation. If this is the angle of inclination at which the block is about to move or about to slide down, so this will be the normal reaction, and frictional force will always act opposite direction to its motion, and its own weight will act downward, that is mg. And this will be, if this is theta c, and this will be mg cos theta c, and this will be mg sin theta c, where this theta c is nothing but angle of repose. So how do we define angle of repose? Angle of repose is nothing but the angle at which, or the angle of inclination at which, the block's component or weight component will be equivalent to the limiting friction between the surface and the block. Therefore the block is about to slide, so the angle at which the block is about to slide is called angle of repose. Here normal reaction is being balanced by one of the weight component of mg cos theta, and limiting friction is being balanced by mg sin theta. That means limiting friction is equivalent to mg sin theta and normal reaction is equivalent to mg cos theta. So I am writing here. So limiting friction is equal to mg sin theta c, and normal reaction is equal to mg cos theta c. We know that limiting friction is nothing but mu into n. So mu into n is equal to mg sin theta c, and n is equal to mg cos theta c. Let us divide both. So what happens? N get cancelled, mg get cancelled. So what we get? Mu is equal to tan theta c, where theta c is nothing but critical angle or angle of repose, the angle at which the block slides down.